Welcome back to Foiling Week 2022 and our Foiling Week Forum. We just had an amazing announcement earlier about the Foiling Youth World Series, which is totally nuts, but it's going to be around the world and really gives young athletes something to aim for in the sporting side of hydrofoiling. Right now, we're going to be talking with some awesome guests about some amazing projects that are on the way, in the works, just getting started, all over the map, but with some really smart people. So we'll try to digest any really technical stuff for the people with slightly smaller brains like me. So I will introduce you to our guest right now. This is Foil Everywhere. The reason why we title this session that is because we like to see where hydrofoil technology, which sometimes drives decisions where hydrofoil technology can be used in the marine space generally. And in our cases, it's there. Sometimes the technology drives the use, and sometimes there's a demand from society, industry that's looking for solutions that foiling can provide. So they come to us, or we go to them with ideas. And this is a perfect example of that. Particularly in this case, in the commercial side of things. Our guests are Fredrik Falkman on my left from the Swedish Sea Rescue Society, which. Geez, 2 years ago, I didn't think I'd be talking to a sea rescue person. I hope I'd never meet one. But this is something different. And then we have Anders Bringdahl from MobiFly for his commercial applications of hydrofoiling. And we're going to learn all about that, moving in the direction of transport, which is something really important because it combines a lot of values that Foiling Week has as far as sustainability goes. So Anders, welcome. And Fredrik, welcome.
Thank you.
My co-moderator will be Laura Marimon, who is normally here sitting right next to me, helping us all out. She is an engineer, among other things. She's studied a lot of things, PhD, etc. And she will be remote with us. So welcome, Laura.
Hello.
Cool. All right. So, I was just talking about that idea of, like a chicken or the egg thing. Do we come up with developments in hydrofoils and say, I think this would be a great application in certain types of transportation or a certain type of sport. But sometimes transportation through governments or other funding says we need to make ships more efficient. And where can we do that? And they find someone that's in an ancillary business and says, can you help us out? So maybe let's talk with Fredrik and see where foiling fits into your work with the SSRS.
Yeah, so the SSRS is like many European sea rescue organizations. It's a voluntary organization. We have about 2,300 volunteers manning some 300 rescue boats in some 75 rescue stations around the Swedish coasts. And it's no government money, it's all donated, it's all voluntary. Pretty cool that it works. And of course, we run heavily on diesel and gasoline. And some of our donors would like to see changes to that. I think most of them, and we would too. And for a long time, we thought that it's a dream, but maybe it can't be realized. But then we got some funding from the postcode lottery, mostly, to see if we can do something to make this a really sustainable rescue boat or a zero-emission rescue boat. So we started out looking at hydrogen, not hydrofoils, but hydrogen. And we concluded that it's too early still. It would be too much work. Maybe eventually it could be something. So then we turned to battery electric, and it's almost possible. But the ingredient that we're missing is the efficiency, and that's where hydrofoils come in, and it looks like can really make the difference. We don't know yet, but the math looks good.
And what's interesting about the Swedish Society is that it's representative of rescue situations all over the world. Small boats going out in the ocean to rescue people, and sometimes they need to be sustainable because if you run out of fuel during a rescue operation, your range gets limited. We know this with helicopters in ocean sailing; those ranges are limited. And So the RNLI in England is probably similarly a model of funding.
Yeah, and they had this April Fool's joke about having a foiling rescue boat last year, which we tease them about a lot since we're trying to do it now. But yeah, we all sort of built our fleet on very long ranges, and when we look at the data, we hardly ever need all that range. Of course, sometimes we do, so we don't want to take that away completely, but it looks like we could make at least half, maybe 75% of all rescues with quite limited range. So like 15 nautical miles or something. And we usually have more than one boat on the rescue station. So if we can make this sustainable boat really appealing, we can get the volunteers to choose that boat more often, and that way we can still have the diesel boat, but we don't have to use it hardly ever, hopefully. That's the idea.
Yeah, that's awesome. I didn't think about it that way in terms of splitting up the duties, in the craft. And it makes sense. It seems like it's lower hanging fruit to design a hydrofoil electric powered possibly boat when you know that the range is only, and time and sea state is only limited.
Yeah.
Now we're going to be, this is a big picture, 30,000 foot view of that project. And then we're going to get down to the details because I know Laura has actually worked with them too, in terms of how you execute these ideas. That's where the rubber meets the road. That's the longest part of the project, not just the idea. Anders, can you give us the 30,000 feet on where MobiFly came in? Did someone come and ask you for some ideas for efficient craft, or did you come up with an idea and say, this could be used for X?
Well, I think from MobiFly's side of things, we, first of all, my background is from professional windsurfing. That's why, I'm very happy to see you guys sitting over in Lake Garda. This is an awesome place. We've spent a lot of summers over there. But the use what's interesting for me today is that you see all the technologies coming from windsurfer, kiteboarders, into Formula One race cars, into airplanes. And today you can actually mix all these things and create things with it, which is really cool. And MobiFly, the idea, my old company was called Sea Bubbles. We did a small hydrofoil electric boat that was supposed to be, catch a bubble on your phone and work in the cities as a Uber type. The situation was really cool. So we proved already back in the 2016 the use of batteries with foils and so forth. Now, of course, we are all up against a market that exists for 50, 60 years. If you look at the combustion engine, how it's been perfected and so forth, the idea with MobiFly was just to go faster, longer, more efficient, and really push the efficiency for this, because it's the autonomy that's interesting, that people need it. We're talking the sea rescue in Sweden, that it's all good if you have a zero emission boat, but somebody's about to die that is a little bit too far out for where you need to go. That Houston, we have a problem, that doesn't work. So we came from the point more of saying that it's a scalable platform. So we fly a scalable platform. The cover is something, okay, it's important when you're talking air drag and so forth. Use a little bit of ground effect if you can. Everywhere you can use energy, use it. This is the biggest difference between the diesel, where you can just throw in, as we call it, dirty diesel into your boat, or you go the way where you say, look, we have to be as efficient as possible. And that's where the foils open up the world, because there's so much less drag in such a product. And that means that zero emission, be it battery, hydrogen is coming, whatever, you be better off. So that's a little bit the target. And then we said, okay, for us, where's the main nail to hit, so to speak? And we started looking at public transport, because it's something, we have boats that's crossing all day long. And you can attack it in a way. What we believe is that for anything to change, people have to want to change. If you want to change, that means that the product is more fun, intriguing, I want to try that out, more comfortable, it makes economic sense. So the operator is not going to go, Jesus, that's nice, but it costs 5 times more than what I pay today, so that's not going to work. You have to calculate out your TCO, public operators, we're talking 25 years, TCO, total cost of ownership, right? And make sure that all of this balls into a package, then you say, that's a really good deal, let's go for it, right? So that's a little bit where we came from with Mobify.
Awesome. As far as support is concerned, Anders, you mentioned the idea that you're going against years and years of history of, and I mentioned it in my notes to you all, the energy density of diesel is still so good and so hard to beat. But our governments, with a lot of, climate accords and all these other things that are trying to see how you can reach certain emission goals, and low emission goals around the world. In Sweden, Anders, are you in what country are you in?
Well, I am Swedish from Stockholm, but company is in Switzerland. Right now I'm sitting in a production factory in Portugal.
Okay, cool. Awesome. So even though there's a lot of history there and a lot of resistance, for both of you, the government funding route, are there avenues starting to open up that way? Maybe we'll go back to Frederick and then we'll switch to Anders. What's your experience?
For us, we sort of took on some extra weight when we were founded in 1907, that we don't want to have any government money, because we also need to be able to put our thumb in their eye every now and then. We had the rescue helicopters all of a sudden were in Afghanistan, and so then we have to roar. And it's difficult to roar if you also need to go with the money bag. So there's no government funding for us, but I know that others, the Coast Guard, the military, pilot services, they are all going to have to go this way. So if what we do together, this community can help that. I think it's awesome.
Awesome. And Anders, for you, as a business venture, but it's an altruistic business venture. So it's almost like your ideas are non-for-profit, like Frederick's, but you have to fund these things. What's your experience with the funding side of things and government's interest, and where do you get help from?
Well, I think there's a lot of funding today on European level for the transition, in effect, and the question is larger than us, because it's end of the day for us on one side, we love the idea that we're trying to do something good that's going to actually help everybody in that regard. But from a funding point of view and governmental aid, the aid comes for the transition. It doesn't make any sense today that your sub money goes into paying for dirty diesel boats to continue polluting, when they could go straight into the operators to operate the boats that on the TCO suddenly starts to make sense. We're coming back to the economic sense. And at the beginning right now, what everybody's facing is that, we're talking hydrogen, great, but these things are expensive. And the pill to get into today without having a certain future is kind of a little bit of wow, that's a tough one to bite, right? So that's where the European and the government are funding as a pilot project makes a lot of sense, because that means the operator goes, okay, it's not so bad for me. I may even come out a little bit better than if I continue with my old boat. And always remember, you look at most public transport companies today, they don't build the boat that it is yesterday, Most of these boats are in the water already for 10, 20, 30 years. And all they're trying to do is to milk it for more money, because it's cheaper for them just to change some oil filters, maybe a motor, and then keep running the same thing that pollutes just more and more and more. For the customer, the seats are older and older and older, and it's not a positive situation, right? So I think from this point of view, it's the operators that needs that push to be able to get into new product, to create a bit better situation for themselves and for the customers that they have, and then hopefully land on guys like us that go, hey, this is a great idea. This is how you can do it, right?
Fantastic. And so now we're going to get into, and this is where Laura really comes in. I know, Laura, you have ideas about the big picture, but what I want to talk about is the hardest part about this whole thing, which is the execution, which is making design decisions, thinking about what craft, what application of these technologies, foiling technologies that we talk about here, propulsion technologies, make sense for the application you're aiming for. We have about 20 something minutes now to talk on the technical side of things. And so that's not a lot of time. But what we will start with is, Frederick, in your preliminary research, it sounds like a pretty cool boat, a rescue boat. Maybe we won't do hydrogen, but if we had these magic wands and we knew what we were capable of, what does the rescue boat look like?
It's gonna look like a flying rib. We're building a 0.6 scale, which is going to be 6 meters roughly, and till next summer, hopefully 8-9 meter version. We have all our boats have a top speed of 35 knots. We don't want to go faster because it just creates other problems. So that's what we're going to aim for. We don't want to build a slow boat. And we're really aiming to make, so our mantra is we make this boat easy to choose. The volunteers should want to choose this boat. And I think that quiet, no noise, no fumes, no vertical accelerations, that's going to be a very good thing in this regard.
In terms of acceptance.
Yeah, I hope. And of course, it's then also very important that the boat is trustworthy, that it's not, it won't throw you off, for example, or crash or something. So that's what we're aiming for. But I think that there will be so many uses for this kind of boat, like coach boats, chase boats.
Yeah, there was just a picture from Keel Week last week with all the ribs lined up, and I think the original person who took the picture didn't mean much by it, but then Lars Grail chimed in and a bunch of other people chimed in and said, oh my goodness, come on. That's a lot of emissions right there for one regatta.
Yeah. So wherever this event is next year, we'll try to bring it.
Cool. And Laura, you're familiar with the SSRS project. Can you tell us a little bit of technical points in terms of what this design brief has driven in terms of the craft and what the limitations are, maybe?
Yeah, so my colleagues at SPA, through actually some research funding as well, we've been working a bit on the project with the SSRS. But of course, the main challenge for the sea rescue, but also I guess for ferries in the future, is reliability and robustness, and especially when it comes in rough conditions and wavy conditions. So the brief is kind of on the stability side of things, is really important, and how to get knowledge and access in systems, and how to work them well to be able to fly reliably throughout all the conditions that are faced, especially in Sweden would be in the west coast more than in the east coast, but where it's a bit more calm.
Is there in your kind of first look at the situation, is there a type, we're talking about, Rick mentioned ribs, which are, pretty useful design all the way around. Is there a particular foil kind of shape and concept that's existing or that can be modified to be, fit well for how those boats are going to be used, where they're going to be used, how fast they need to go?
For sure, there is a initial push now. All the clubs in Sweden, for example, if you have ribs with actual foil, you need to have ventilated areas to use fuel and stuff like that. So changing to electric engine for sure is something that a good option. And I was in Kiel last week, and with the Nacras foiling upwind now, And now, of course, having all the ribs kind of stuck up on the starboard ley line, creating waves, is really not a good thing. It's not only for the environment, but for the racing as well. So having ribs that potentially have coils, and then therefore create less wake and less waves for all the other Olympic classes that are racing, not only Olympic, but any coach boat around the world. If it doesn't create waves, it would be kind of beneficial.
Yeah, I hadn't even considered that aspect of it. I was just thinking literally fuel consumption.
Yeah, it's not only fuel consumption, but also wake creation, and this is especially important as well for SSRS, for example, having the possibility of both kind of being able to foil, some occasion not foil, how to deal with that. It's quite important.
Awesome. And I was just thinking about rescue operators' backs, when they get pounded just going through the waves, on a rescue mission. But that brings me to Anders and, the customers and transportation. It's not a dissimilar thing. Comfort's really important too, but let's get into the weeds a little bit with your concepts as far as types of hydrofoil applications on transportation and what you've kind of boiled down to is needed to make this look attractive, like you said, also be, hopefully affordable to make visit, but the ferries have to last a long time, right? So tell me about your application.
Well, I mean, as a design brief to begin with for Mobifly, like I said earlier on, we push the performance as much as we can. That means that we have to look at all sorts of sea conditions to see how you can actually operate the foiling boat in that condition. Today, there is ferry boats that goes through quite a lot of waves. There is some conditions they actually stay inshore because it's too heavy for them. From a customer point of view, we're talking about seasickness. From an operator point of view, we're talking about keeping up to timetable. So all of it mixes up. So I believe today that the best way to handle all this sort of situation is the different flight controls, different flight modes, maybe accept a possibility skimming situation where conditions will allow that. So a little bit the reason for me to go with a catamaran is that it's a naturally stable platform and allows me to do a lot of different things with this boat. So from there we have, we're looking at design performance of 24 to 28 knots cruising speed with peaking a little bit over 40, 42. With 60% usage of the battery, we get 80 kilometers with a 30-minute recharge. So if we flatten out the boat, we get up to 120, something like this in distance. So it's a start. It starts to be pretty good. I believe a lot of operations that can handle the 80-kilometer range, recharge in 30 minutes and go back and do it again. It's pretty good. So I think that's where we are today. And as far as sea state goes, it is the same thing. The flight controller, we have one of our founder, Ricardo Bencatel, who's in the base of a lot of these sort of projects. And he's the one to talk flight control more than me. But the challenge from uneducated eye is to how do you handle chop? I'm saying chop up to 1.5 meters, something like this. And how do you handle a 14-second swell? Because suddenly you can't cut it in half anymore, right? So in there you have to get to the point where a flight controller can distinguish what is a swell and what is a chop, and the boat allows to follow the surface of the swell but cut the chop in half. So I mean, this is a little bit the things, and I think a lot of these things will come together quite nicely in the future, is what we're working on. And to begin with right now, the routes that is perfect for a foiling boat is obviously where you can define one or the other, right? So either it's massive ocean swell or it's the chop, and the distance lives here. The good part for public transport routes is that I would say 90% of all, 80% of all routes that exist in the world for fast ferries, if you put it like this, are all in the range that today we can handle with electric or a range extender hydrogen, and it is pretty good like that today. And then as the years goes on, knowing that if you're talking about foiling electric boat and you look back, you see it's we're kind of starting at this stage, right? So I think it's the usage of all this package in the years to come will accelerate very, very quickly.
Awesome. Well, that you got me thinking in terms of, the different sea states. Obviously, it's easier to set things for a more consistent or known sea state that you have, you're able to handle. Laura, I want to throw that over to you, because in Foiling Week, we find out new technologies are pushed more in some spaces, right? We had the Eagle class catamarans worked really hard for the last couple years on sonar technology and for autonomous and sensors for ride height, autonomous ride height. And in the America's Cup, obviously Team New Zealand and Luna Rossa before then worked on autonomous ride height to test and eventually, control flight. Laura, where do these other industries and knowledge people, how do they get, two Anders, and two Frederick, when they're working on something in some other corner of the world? You're lucky enough, you get to see these technologies. How do these technologies get to be combined in the people that have that knowledge?
Yeah, I think in Foiling Week and foiling in general, we are very lucky because we don't really only attract the normal naval architects, but all the aeronautics, advanced materials, systems engineers come together now, and it's extremely interesting to see and challenging, of course, but the possibility of having knowledge a bit like what is happening in the America's Cup teams as well, getting knowledge from Formula One, from kind of all sorts of different mechatronics, like all sorts of different engineers to one specific boat is really is a complex system, and the traditional naval architects need to work a bit hard on it to kind of gain the knowledge. But I think it's very nice to see how you can trickle down the technology. We saw it with the Flying Nick as well, I guess, and this possibility of using technology that is already kind of available to be taken and made with advanced.
Well, yep. And I have now I'm going to go back into the big picture side of things, and I'll start with Anders and move to Frederick. As we've seen, Anders, just like Frederick said, I'm a big fan of yours. And actually my favorite video is the transatlantic windsurfing race with you and everyone that was in that. So I just have to give my fan moment. But you've seen, what it does illustrate is we watched your professional sailing career, windsurfing career. You were a star, and we watched that windsurfing evolve very quickly from the original windsurfer, which you were probably a little young for, and moving all the way through into huge fans and professional series. And now we see foiling windsurfers, kite foiling, wing foiling, and in a very short period of time. When we talk about these projects that Frederick's working on and Anders working on, Laura's doing engineering for, everyone's starting to see the possibilities in our sailing world. We've seen the change happen so quickly. Anders, do you have a little bit of anxiousness? Like, do you have this it can't happen fast enough idea for the change, because the barriers to transportation, but you want to be successful, you're a competitor. How do you balance this want people to see the light and make these changes, and but still keep your head down and try to take each step at a time because there's resistance?
Well, I think that's a little bit where it comes down to having a very solid and good team around you. Because myself, knowing my background, I will always shoot a little bit for the stars, and it's always good to have somebody to put you back on the ground, saying, "Hang on a second, maybe not quite yet. we'll get to that part, right? So I think there's always a mix between dreams and reality. And today, what's really cool is that, like Laura just said, just look at the America's Cup, what they did with the last cup in Auckland. You know, the first time, I don't know about you, but first time I saw the boat with the swimming, you know, flying arms, and you go, what? That can opener is going to open the side of the boat. This is not going to work. And suddenly you see what they did. When you go, you got to be kidding me. I mean, this thing is so efficient. It's unbelievable. So I think it's, you know, the sailing world as per se has adopted the foils, and it changes the athletes as well, right? I mean, just coming into, do you tack on a little header, or do you know, there's so many things that changes the aspect from this, and then you come into to the normal boats, even private boats, the foiling aspect that you don't bounce around. That's Frederick as well. I mean, the thing that people don't realize as well with foiling boats in a rough sea state is that you also have this aspect of everything just gets calm. You know, it's one of these situations where you have a massive foil being pulled up out of the water and back down that slows things down. So it's, you know, even if you're operating outside of foiling excellence like this, you stabilize the boat with the foils as well. It's a massive keel below the water. So I think there's a lot of these sort of things that are interesting as well.
Awesome. And my apologies. We have, let's see, David, we have David.
Yeah, no, I've been listening, Chris. So
there we
I've been
go.
having all the great conversation, so no problem.
Good. That's my apologies. But we have David Tyler from Artemis Technologies. And David, you've been following along with this. Artemis Technologies is something that, you know, almost has grown out of the evolutions in sport hydrofoiling, particularly with the Swedish America's Cup team. And we've talked to Ian Percy about the developments with Artemis Technologies. Your group has seen these challenges that Anders is facing, the resistance, but with the big ideas to say, where can we apply what we're learning? You know, this is like a push technology in Anders' side of the thing. You know, we have these ideas, we can push them into the transportation space. And the same thing with Frederick, really, although Frederick, they have a demand for, you know, from their community, from their support to reduce emissions. And that drives them toward, you know, they want to pull that technology toward them. David, give us the update on Artemis Technologies. You've been trying to tackle this problem for a long time.
Yeah, certainly. I mean, just kind of following on from what Anders was saying, we had a group of us in Bermuda. We did pretty well. Didn't quite beat Team New Zealand, but I don't think we were too far off. But obviously, they're a fantastic team. But seeing these boats, you know, seeing them doing 50 miles an hour, 4 times the speed of the wind, is just incredible efficiency. And as a group, it was the same time that the IMO were getting almost 200 countries together to commit to reducing their emissions. So, you know, led by Ian Percy, really, and a few of us, myself and a few guys from the engineering team, we really started to look at, well, there must be more to this technology. What applications within the commercial sector could be used to support decarbonisation? And obviously Anders and sea bubbles and things were, you know, they were sort of happening after that period too. And so we set off to really develop our e-foiler system. Because a big challenge with sort of foiling technologies in the past is they had drive shafts in the vertical structures. They had a lot of metal under the water. So although you may have been delivering a little bit of ride comfort, you weren't getting too much efficiency. So we really kind of went back to basics and looked at how the development of the foils through the cup could be brought into that sector. But yeah, today we launched our 10-ton prototype a few months ago. So we've been running sea trials in Belfast. It's been going really well. We also have the sister ship of the boat with 2 gasoline outboards. So we're in a really nice position where we can do 2 boat testing and direct comparisons and every day that we go out. We have accelerometers on the boats. We've got cameras measuring the weight generation. We've got, you know, lots of sensors, lots of fiber optics on board. So we're really in a position now where we're validating the performance of technology and using those learnings to really develop the larger systems, the bigger boats coming down the line.
And that idea, you know, I started that with Anders, like, are you anxious? And you said, you know, I'm the kind of person that shoots for the stars. And David, it's taken a while to validate what you're working on, right? With this technology. From this point forward, you obviously still might have some barriers. Where do you see, this is going to wrap this up in terms of the future side of things, but where do you see the project really, what needs to happen for these kind of technologies to move into those transportation spaces? Go ahead.
Yeah, sure. I think the foiling bit is a relatively straightforward bit for us because that's been our world for a very long time. Even the flight control system, even in Bermuda, we had an autonomous flight control system. Nathan was driving the boat, but when we were learning how to sail the boat to its optimum, we're actually using the autonomous system to kind of control it. It's just because you weren't really allowed to use a computer. The computer is always going to be a lot better than the athlete, unfortunately. Water's, it's 800 times denser than the air. It's a very, very bumpy sky. And I'm always going to back the computer over any human trying to control that boat. So that stuff, we're confident there. We have our simulator in Belfast. We use that to optimize the flight control systems, run different software codes, run different foil configurations. So we've always been in a good place there. The big challenge for us was the integration of the propulsion systems, development of the batteries as well. So we developed our own 800-volt battery, and really bringing along the class societies, and in our case in the UK, the Maritime and Coast Guard Agency, to give them confidence that what we were designing and building is safe for use. So that's one element, and we're kind of taking the class societies on a journey with us because they don't necessarily have the expertise that we have. So that's been the biggest challenge for us. We kind of know what's safe, but they don't, and so this is the power. This is the power of having the test mule that we have now, is that we're actually able to validate the simulations that we showed them a few years ago and say, no, look, this is the data, this is what we said. We're very confident about the technology.
Awesome. One of our discussions on sustainability later on is going to come from Boundary Layer Technologies from California, from northern, kind of a San Francisco area group working on small foiling container ships. And, the scalability of these things, it's really awesome talking to Laura and Frederick about the Sea Rescue, because scaled down to smaller boats like we see here in Lago de Garda, we have a Torpedo foiling coach boat, we have the Candela Recreational luxury boat, and then just all the small foilers. It's really cool to see that you can get this done in the small boats, but what Anders and David are trying to validate is a much bigger deal. I wanted to ask Laura one quick question. In scaling, you're working with container ships, Wallenhaus, or I'm trying to remember the name of the company, but you work with
car carriers.
Car carriers, and with various ways of creating efficiencies in transport. What's the biggest issue from an engineering standpoint? And we don't have that much time, but really quickly, what's the biggest issue with scaling up hydrofoiling?
So what we need to deal with in all the scaling, which is whether it's wind-assisted propulsion with the car carrier or foils, are these non-dimensional numbers. So normally for a normal hull, it would be called the fruit number. So you can go through a number of different tests with the much smaller scales, both in CFD because it's a lot quicker, but also in towing tanks and stuff like that. What happens when you start adding foils or lifting surfaces, which are wings, for example, is you start dealing with the Reynolds number, and these are not directly comparable. So it's quite challenging to achieve the same performances on much smaller scales if you want to test them. But there are kind of good ways of looking at those problems and not doing kind of geometrically scaled rudders, for example, or foils or wings or stuff like that. And the other thing with the foiling, which, of course, when we want to get knowledge from other industries, from other engineers around the world, is that our aeronautic friends, they don't have free surface. So what we deal, especially at super high speed, for example, can be cavitation, and also at a bit lower speed, but very close to the free surface, we can have ventilation problems. So dealing with
I'm
scaling.
gonna stop you just for a second. Is the free surface the air-water interface?
Yeah, sorry, the interface between being underwater with the foil and just kind of on the edge of over the water.
Yeah, cool.
So we see, as Anders was saying, like if you want to have a fast boat, you also have to optimize the aerodynamic side, so all the part above the water. But when in this very close to the free surface, the pressures change a lot around the foils. And so we need to deal with the kind of these other physical phenomena. And so learning from different scaling, learning from different, how we can change the sections slightly, change the geometry slightly to be able to test a different condition is quite important.
Cool. We're going to have to start to wrap this up. So I'm going to start with my final question, which is this dream for the future. Sometimes these mountains seem impossible. Anders and David and Frederick can picture certainly what they want and where it fits in the world and how well will it work. But Frederick, what's your dream like next 5 years? What would you like to see for your organization? You're obviously working really hard on this. The things that you're working on can actually save more lives potentially, or at least make it easier for the people trying to save lives. So what's your dream?
So we have this very fortunate situation where we pretty much rescue everyone who can make the calls themselves. We have like one exception in the last 10 or 15 years, which is of course fantastic. So I think it's making life easier for our crews, our volunteer crews, and being more sustainable. And we've had this sort of half jokingly in the project saying, whatever your problem, foils, that's the solution. I don't know if that's really true, but I think we're going to see a lot of benefits coming from this.
And like Anders said, it has to be attractive. It has to work.
Yeah.
Obviously, the cost of these things is the bottom line for companies. Anders, so your dream for the future, you're a dreamer. So let's go full send on the dream.
Well, it's kind of hard to say that like that. But if you just take a step back, we're actually talking about boats that cannot fly, right? So we're already at the Jetson level of action, right? I mean, look at all these foiling things today. They're kind of out there, right? So what I see and what I hope for the future is that we can all kind of settle into one way to charge these boats, get some sort of industry standard on voltage. So we can, we run like David just said as well, we're on 800 volt systems that we created ourselves, and make sure that the class society follows through, and that we have A60. So that means our battery pack can burn in the boat for an hour before we have any issues. But there are these sort of things that could be easier, and that as a community we can all work to create together. Because the reality is it's us against them, right? It is something that's going to have to change. Is the transition. So to make that transition as easy as possible makes sense, because then there's so many people that are way smarter than myself around in this room that I can add into all these sort of things. And I think that's a paradigm shift. That's really cool.
Awesome. And David, it's kind of hard to top that one. What's your dream? I know you're very goal-oriented human.
No, certainly. I think we're making our dreams a reality now. So we're kind of into that phase where we're launching a 150 passenger ferry in 2024 that's going to run between Belfast and Bangor. So that's a 12 nautical mile route. In 2025, we're going to be launching a 24 pax crew transfer vessel that we're looking to decarbonize offshore wind operations. And then next year, we're going to have a high performance luxury boat coming online as well too. So I think we're launching prototypes of lots of different applications, but obviously the dream is that this technology is adopted, that myself and Anders program too, and the other people doing things around the world, that we can prove this technology and operators do take it on board. And I think there's a big policy change to try and drive this transition. And Anne just mentioned that before. My dream is that actually people take decarbonisation of this sector seriously, and they put the money that's required to make it happen.
Awesome. And I have a feeling that, those projects that you're working on, when they get executed and when the sea rescue boat gets executed and as Anders' project begins to move forward, there must be some kind of snowball effect. I'm pretty confident of that. And it's not quite there, but man, it feels really, really close right now. Don't you think?
Yeah, I think we're getting closer. We're certainly getting closer. And obviously the work that Anders did with sea bubbles was really, that really kind of kicked it off in a big way in the commercial sector. So, yeah.
Great. Well, here at Foiling Week, we like big ideas, but everyone's so smart that we won't, and we're competitive. So we don't settle for a big idea that goes nowhere. So we're going to keep working. Thank you, David, Laura, Anders, and my special local guest here in Lake Garda. We miss you all. So let's work on getting you on the shores of Lake Garda next June. But from Foiling Week 2022 and the forum, we have a Super Techie America's Cup technology specifically having to do with the hydrofoils and what's put into them coming right up. But thank you, guests. I really appreciate all your time and knowledge and your stoke. So enjoy the next round, and thank you again. We'll see you in just a moment.
Thanks a lot.
Ciao.
Bye.
Yes. Ciao.